This is going to be a quick video on like a harder example of implicit differentiation. So a curve C has equation cos y is equal to x for x between negative pi and pi. Use implicit differentiation to show that the second derivative of y with respect to x is equal to negative cotangent of y times dy by dx squared. So how do you do that? So let's start with this equation here. So let's take the first derivative on both sides. So you would have derivative of cosine y is negative sine y times dy by dx. If you don't understand where this came from, you should probably watch the first video on implicit differentiation. And then this is equal to derivative with respect to x of just x, which is just 1. So that's the first derivative, but we don't really care about that. Now we take the second derivative. So let's take derivative with respect to x on this thing again. So the derivative of negative sine y times dy by dx. So treat this as two different functions. So you have negative sine y as one thing and dy by dx as the other. So the derivative of negative sine y is negative cosine y times dy by dx. And then is the product rule, so we just multiply it by the second function, which is dy by dx. Plus, well, you left with negative sine y, which is the first function, we don't do anything with that. And you multiply it by the derivative with respect to x of dy by dx. Well, what's the derivative of a derivative? That's just the second derivative, right? So you just have the second derivative right here, d squared y by dx squared. And this is equal to the derivative of 1 with respect to x. That's just 0, because the derivative of a constant is just 0. Well, so now you have minus cosine y dy by dx all squared minus sine of y times the second derivative of y with respect to x is equal to 0. Well, now we can just rearrange this equation, right? So you're left with negative sine of y times second derivative of y with respect to x is equal to, we bring it to the other side, you're left with cosine of y times dy by dx all squared. And now you want it in this form right here, second derivative of y with respect to x. Well, you can just divide by negative sine y on both sides. So you're left with the second derivative of y with respect to x is equal to, well, what's cosine divided by negative sine? That's just negative cotangent of y, of course, times dy by dx all squared. And that's exactly what you have to show. You have to show the second derivative of y with respect to x is equal to negative cotangent of y times dy by dx all squared. And yeah, that's a harder example of implicit differentiation. This is from a further maths paper.